all that are on my YouTube channel, for those of you that have shared this video out with other folks, if you want to join me on YouTube, by all means do. And as you guys can see, it's panning up. And I think it's going to be like some feedback here, which I'm hoping that it's not. Okay, so I had to mute myself so that I'm able to be here and be with you guys as well. Okay, so let me start over again, guys. For those of you all that are coming in, my name is Professor TK the Chemist, and I do a lot of hands-on science experiments for kids, but I also give away free tutoring Monday through Thursday, 12 noon Eastern Standard Time. I know that many of my students are having trouble. They're on the struggle bus with chemistry. And so this is what I do. I make sure that to give positive information to students that need help and they're too afraid to ask their teachers for the help. Okay, so that's what we're doing today. We're going to go through some chemistry problems. And if you guys got questions, please make sure you all put them in the chat box. Another thing I want you guys to be aware of is that when we're doing our stuff, make sure that you guys have your questions ready for me at the end. So if it's not based on what we're doing during this session, make sure you hold off to the last 15 minutes of our session for me to go over your particular questions that aren't related to what we're talking about today. Okay, so I just want to kind of do some housekeeping here and let's go. If you guys ready, I'm ready. Let's get into it. First thing, make sure you guys have what? Your calculator, your books with the periodic table in it, your pen, your paper with your notes, and a sense of wanting to learn. Why do I say this? Because we've got so much to tackle, and sometimes when we're going through the problems, I love when you guys can go through the problems with me. Hey, Black Venus, how you doing? So I love when you guys are able to go through this with me and we can go through them together. So if at any point you need me to go back over anything and you're like, okay, wait, this is going too fast, let me know that too, and I'll be more than happy to start over. Okay. Hello, little Hoover 29. Hello, Pink Heart. Hey, Eddie. So, hey, Kennedy Elise. Hey, Diana. All right. So if you guys are ready to get into this chemistry lesson, let's go. So several of you guys have requested that I do something on acid-base buffers. So I wanted to kind of go over that with you all because some of you guys had questions on that. We've also been talking about chemical equilibrium, and we've done a few word problems with that. And so if that is you, you're in the right place. Now, if you needed help on equilibrium, let me know because I'm going to start there and then move forward with the other parts of our problems. Because what you don't realize is that everything that you do in chemistry is a repeat from what you've done previously. So if you do not get the grasp the concepts initially, you may have trouble later. Okay, you're going to have trouble later. So what I'm going to do right now is, like I said before, we're going to go through a couple of these problems here. I'm just aligning my notes up with you guys so that you're able to see everything that you need to know as we go through these problems. Okay, so that's what you guys see me doing here. I'm just rewinding a couple of things and, getting you all prepared for the notes. And sometimes when I do this, the screen always wants to kind of switch off a little bit, like what you guys can see here. See that what it's doing now. Okay. All right. So what I have for you guys as we talk about chemical equilibrium, okay, what you all need to understand and need to know is that when it comes to chemical equilibrium, there are some boundaries and things that you need to know. So one of the things that we discussed previously dealt with the fact that if you know the formula will help you along the way. So for instance, let me go ahead and zoom in so y'all can see this right here. There we go. All right, so what you've got on the screen is, if you've been rocking with me for about a week with this information, then you know that the formula for equilibrium expressions is products over reactants. Products over reactants. So in this particular question right here, we just want to know, do you know the expression for this equilibrium process? Okay. Do you know the expression? So for instance, as I look at the fact that I have on the left-hand side, I've got my reactants, and on the right side right here are the products. So if you take a look, if you know that you're going to put products over reactants, we can do process of elimination. We can get rid of letter A because letter A deals with the reactants over the products. And we know that's not correct. We also know that letter D doesn't make sense either, okay? So whenever you're taking your test, if you know the rules, immediately get rid of the answers that don't make sense. So we got rid of those two. Now, when it comes to the correct format, you also have to know that if there is a coefficient in front of any of your elements or compounds, those are typically raised to the exponent or to the power of that. So since I know this, I know that the correct answer would be letter C, because you have HCl in brackets raised to the power of 2, because there's a coefficient right here in front of HCl. And on the bottom is your H2 and your Cl2 in brackets. If you would have selected letter B, then you would have been saying that I'm going to multiply the 2 times HCl, and that would be incorrect. So you want to make sure that you know the correct formula in order to find the right expressions. Because as you see, when your teachers give you tests like I do, there's going to be a setup or an assist question. You know, when you're playing basketball, you know, and you say, I need that assist. Well, in this case, if you are looking at the questions, oftentimes the question that comes before it sets the tone for the next question. So if we look at question 24, it says, if the equilibrium concentrations for this system given in question 24 are as follows, find the KEQ. So again, if you've got the right formula and you've selected the right formula, then plugging these numbers in will allow you to get the right answer. When it comes to equilibrium expressions also, you want to keep in mind that it's always moles per liter or molarity, which is the same thing, okay? Moles per liter is the same thing as molarity, the unit. Now, what we're going to do, we're going to solve this problem because we know we have the correct formula. So let me go ahead and scoot this page down so it won't interfere with what we got going on. All right, so I know that the formula that we're using is KEQ equals HCl raised to the power of 2 over, in brackets, H2 times Cl2. Now, what you will also notice is that they've given you, I'm going to zoom out a little bit, y'all, so y'all can see it as well. What you will notice is that they gave you the numbers here, okay? The HCl in this case was 6.25 right here. Now, I don't need to use the units, because whenever you're finding the equilibrium concentration value, those are unitless, okay? They don't include units, okay? So I'm going to put that in brackets because that's going to be squared. And on the very bottom, you're going to put your value for H2, which is right here, 0.450. 0.450, and then times that by the chlorine value, which is also 0.450. Okay. Oops. There we go. So now we're going to plug this into our calculators so that we can make sure that we got the right answer. Okay. So to solve this problem, I've got 6.25 square, okay, divided by 0.450 and divide that by 0.450 again. And I get 192.9. But we're going to actually round that off to 193 because we need 3 significant digits anyway in our answer. And if you look at it, you know that the answer is B. 193 is your answer, okay? Now, if you would have used the wrong formula, let's say that we use letter A's formula where we were multiplying 0.450. Let me clear this out. 0.50 times 0.50. And then divide that by the other number, 6.25, okay? And it was times. Well, if you look here, you'll see that your answer looks somewhat, let me do that over. We had 2 times HCl, so let me put that in correct, 6.25 times 2. So that was the number on the very bottom, 12.5. If we were using this formula here, letter A, okay, remember that number, 12.5 for the bottom. The top is 0.450 times 0.450 equals, and then divide that by 12.5, you would end up with 0.0162. Well, if I move my decimal over 1, 2 places to the left, to the right, excuse me, then I would get this answer here, letter A. Okay, I will get letter A's answer. So this is why you want to make sure that you have the correct formula in order to do your problems. Okay, so if you would have used either of these outside of the correct formula, you would have gotten that question wrong. So again, the correct answer is 193 using formula C. Okay, 193 using formula C. The next question, question 26. Okay, again, even though you don't, matter of fact, let me see here for this one. I cut the formula off for that one. Let me see here. And okay, so we won't be able to do that particular problem because I do not have the formula for that one, or as far as the chemical reaction for it. Actually, yeah, I do. I'm going to use the one that came before it. Yes. So this is it right here, guys. I'm going to actually scroll up right here. Okay. So you all can see that. So as you all can see right here, this is the formula right here. 4HCl plus O2 at equilibrium with water, which is 2H2O plus 2 Cls, okay, Cl2s. So now what we need to do is use that formula for this problem, okay? Let me make sure right here. ClH2O, O2. Sometimes, yeah, sometimes they'll put the wrong, well, in some books, okay, but again, you wouldn't realize it, but I know. In some textbooks, they'll give you the wrong problem. Like they meant to say, look at question 25. And as a teacher, whenever we're assigning problems, we have to make sure, like we have to do the problems to make sure that they're going to be correctly done when you guys do, because you're not going to know the bumps in the road. Okay, so let me go ahead and write this problem down so that I don't have to keep scooting the screen back and forth. So we have 4HCl plus O2 at equilibrium with 2H2O plus 2Cl2. Coefficients are important. Coefficients are important. Most teachers, if you're taking an honors class, or if you are taking a chemistry course on the collegiate level, your teachers will assume that you know how to balance the equations. However, if your teachers do not balance the equations, you need to make sure that you balance the equation, okay? Some teachers are not generous to do that, okay? I'm just saying. Some of them are not. So here you got 4HCl plus O2 at equilibrium, and then you've got 2H2O plus 2Cl2. All right. Thank you, Thomas. Now, what you're going to do, you've got to first write the KEQ for this chemical reaction, okay? You've got to write the KEQ for this chemical reaction. So that means we need to write the proper format. Remember, it is products over reactants. Products over reactants. So therefore, because I know it's products over reactants, okay, let me write that out so y'all can see that. Products over reactants, we have to make sure that we know which side is the product side, which side is the reactant side. The left side is the reactants, the right side is the products. So I'm going to put in brackets H2O raised to the power of 2 times Cl2 raised to the power of 2 divided by HCl raised to the power of 4 times O2 with nothing raised, okay? So now we've got to plug the values in that they gave us, okay? So for instance, let's look at the formats of what they've given us in this problem. They gave us H2O, okay, the concentration for H2O. They gave us the concentration for chlorine. They gave us a concentration for HCl. And they gave us a concentration for oxygen, okay? So you have all 4 numbers. All you have to do now is plug those in, okay? You just plug them in. So KEQ equals, so on the top, I'm going to write out 5.8 times 10 to the negative second power squared times chlorine's value, which is also 5.8 times 10 to the negative second power squared. All of that over HCl's value squared, okay? So I'm going to go back and pull up HCl. Let's see what that number is so we can get that in the problem. 1.2 times 10 to the negative third, but that's raised to the 4th power, times oxygen's value, which is 3.8 times 10 to the negative 4th power, okay? So you've got to write all of that in. And I know, again, in chemistry, writing down all these steps can be tedious, but it's well worth it when you get the final answer, okay? It's well worth it when you get the final answer. Now, because of time, okay, I want you guys to bear with me as I write these down. But in the meantime, keep tapping that screen so that the notifications can go out to TikTok land that, hey, Professor TK the Chemist is in the building giving away free chemistry tutoring. Okay, so make sure you guys continue to tap the screen, share this out, and I really appreciate all of you guys' assistance in this. And to YouTube world, how y'all doing over there? Okay. Thank you, Bianca. How you doing today? Hey, Jocelyn. Hey, Alex. Hey, Kaylee. So I'm going to write down the numbers that I calculate, guys. As a matter of fact, I'm going to show y'all on the screen. 5.8 times 10 to the negative second power squared. Okay, so that's the top number right there. But I'm going to write that 2 times. Okay. So on the very top, I'm going to switch the color so y'all can see this. Okay. You've got 3.36 times 10 to the negative third power times 3.36 times 10 to the negative third power again, because this number right here is the same thing as that number, okay? Divided by. Now, I've got to do this large number here raised to the 4th power. Okay? So now, let's see here if I remember 1.2 times 10 to the third power raised to the power of 4. Okay, let me show y'all what I got so that way y'all will know. On my calculator, I can't tell you about yours, but on my calculator, I have 1.2 times 10 to the third. That's for that one over on the bottom, raised to the power of 4. So I have to plug this in and put 4 there. And this is the number that it gave me, okay? 2.07 times 10 to the negative 12th power. And then I'm going to multiply that times 3.8 times 10 to the negative 4th power. Okay, so this is the bottom number right here that I'm going to write. 7.88, because I only need 3 significant digits, times 10 to the negative 16th power. Okay, again, this seems like a lot of work. It is when you're writing everything out, but you can also discover how easy it is to make mistakes. And that's why I'm writing every number out so that if I have to go back and look at something again, I will know where I missed the mark, okay? So I'm gonna go ahead and multiply these two numbers right here. The 3.36 times 10 to the negative third power. I'm gonna do that twice. Okay, so I get, again, for this top number, 1.13 times 10 to the negative 5th power. Whoops. Okay. Divided by, again, that number that's on the very bottom, 7.88 times 10 to the negative 16th power. Okay. So I'm going to take those two numbers and divide. Equilibrium problems can be very long and tedious, especially when you have exponents that are high, especially when you're given 3 and 4 different elements and compounds that you're having to solve for. So I'm going to go ahead and divide all these numbers out. And I get 1 point as my equilibrium, 1.43 times 10 to the 10th power, okay? That's the answer right there for this particular equilibrium problem, okay? That is your answer. So what I'm gonna do is kind of let you guys marinate on that for a second, okay? Marinate on that for a second, and then we're gonna move to the next problem. Okay. No, it should not be negative 10. And let me tell you why. Very good question, though, user 1874. Very good question. Here's why it's not going to be negative 10. Here's a little math trick. Because that's negative 16 on the bottom, when you bring it upstairs, it becomes positive. So it's like you're saying 16 minus 5, and you get 11, but then you have to move your exponent back one place over. Okay? So that's why. So if you bring the bottom one upstairs, that's like saying 16 minus 5. Or if you bring the 5 downstairs, that's like saying negative 16 plus 5, but you're still going to end up with the same answer. And let me show you the answer right here so that way you will know. Okay, you see this answer right here, number 26? Right there, 1.4 times 10 to the 10th power. Okay. All right. Any other questions? Any other questions? Okay. So now we're going to go ahead and move to the next part of your problem. Hey, Karen. Hey, Jordan. Hey, Lily. All right. So now let's do 29 because this is a little different, okay? This problem is a little different. And why is it different? Well, it's because in this problem, you're having to look for the concentration of one of your elements. See, previously, they were looking for KEQ. But now in this problem, you're looking for your concentration value for one of your elements. And how do we know that? Let me show you. Right here, they gave you the KEQ, which is 6.59 times 10 to the negative third power. They gave you the concentration for NH3. They gave you the concentration value for H2. But then they said, all right, well, what is the concentration of N2 at equilibrium? So Department of Transportation, I did some of the ICE tables before. I did those yesterday. Is that what are you requesting an ICE problem? Okay, so now what we're going to do is get the original equation, which is KEQ equals, again, I'm going to say this again, products over reactants. And since we know the products are on the right-hand side, we're going to put NH3 on the top, raised to the second power. Why? Because there's a coefficient here of 2. So that's where the 2 comes from. And on the very bottom are my reactants, N2 and H2. But H2 is raised to the power of 3. Now, they're telling you, though, hey, I need the formula for nitrogen because that's what I want to know about. So let me rewrite this again so you all can see the formula. And you're going to watch how I'm able to isolate one for the other. Okay, so right here, okay, I'm going to zoom out a little so y'all can see this. So right here, okay, you've got the original formula. If we were looking for KEQ, this would be the formula. We would use this formula, plug in the numbers. But in this particular case, though, excuse me, they're saying, hey, I want you to find N2. So these two right here are going to swap, okay? They're going to swap. And when they swap, you're going to end up with N2 on this side, okay, equals still NH3 is going to stay on the top. And on the very bottom is your KEQ times your H2 raised to the third power, okay? So now y'all know what to do next, right? Plug in the numbers that they gave you. So the NH3 value, let's go back to the numbers so y'all can see it. The NH3 value was 1.23 times 10 to the negative fourth. 1.23 times 10 to the negative fourth, and that's squared, over the KEQ that they gave you in the problem. Let's go back to that one too. 6.59 times 10 to the negative third power. 6.59 times 10 to the negative third power times H2's value, and that's tripled, which is 2.75 times 10 to the negative 6 power. 2.75 times 10 to the negative 6 power, and that's cubed. Okay. If you have a handy dandy calculator nearby, you all can do the numbers with me. I'm going to plug in and do the top number first. Okay, so I've got 1.23 times 10 to the negative fourth power, but that's squared. So on the top, I've got 1.51 times 10 to the negative eighth power. On the very bottom, I'm going to do the cube part first, okay? That's 2.75 times 10 to the negative 6 power, but I'm going to cube that. And I get 2.08 times 10 to the negative 17. But I'm going to go ahead and keep all that in because I'm going to now multiply that times 6.59 times 10 to the negative third power. Now on the very bottom, when I multiply these two together right here, okay, these two numbers, I end up with 1.37 times 10 to the negative 19 power. This is going to give us our concentration value for nitrogen. So I'm going to go ahead and take it back to the top. 1.51 times 10 to the 8th power, negative 8th power, divided by 1.37 times 10 to the negative 19th power. And this, ladies and gentlemen, is your final answer. So Damani said, my professor lost me at nomenclature. Now all this looks like jumbles. I know. Damani, are you taking this particular chemistry right now? And this is your answer right here. 1.10 times 10 to the 11th power. Chemistry is nothing but symbols and numbers. It is a lot. I know it's a lot. Okay, so Damani, you would probably have to, this is in chemistry 1 as well. You probably haven't gotten to this part yet. Have you started on acids and bases? What are you on right now, Damani? Tell me that. What are you on right now? I know you said nomenclature. Okay. So are there any other questions about any of these problems that we've just done? Okay. So now, oh, gotcha. Somebody said, yes, we know about acids and bases. I'm just saying I don't know anything after we talked about naming them. I just go to class and act like I know what's happening. Don't pretend like you know what's going on, honey, because let me tell you what's going to happen. Your professors are going to assume that if you don't ask questions, that you know what's going on, and you really don't. And then they're going to get mad and say, well, why didn't you come to me before? If you knew that you didn't understand, why didn't you tell me before? So don't you pretend. Go talk to your professor during office hours. Yes. Okay. Go to your professor during office hours, or go to your tutoring center. Or better yet, come and holler at Professor TK the Chemist. Because see, I will get you all the way together during a tutoring session. I'll make sure that you don't leave confused. Okay. Now, okay, so Among said we are learning this right now in Chemistry 1B, but not 1A. Okay, yeah, so there are different levels. Everyone is on different things. I know all across the country, some students are on one topic versus the other. And so wherever you jump in at, hey, come on and learn with me. You can learn it right along with your peers. I try to make sure that I stick with what's currently happening, in my area. However, I meet you guys where you're at, because some students are taking chemistry on an accelerated pace where they are taking 6 weeks of chemistry. They're on a quarter system. So some students are learning things at a faster pace, a faster rate. Yes. Now, I'm going to go through something else with you guys that talks about the shift in the equilibrium, because we did talk about this yesterday, and how dependent on what you are looking at and what you have, whether or not the equilibrium would shift, or to the left or to the right, okay? Based on increasing the temperature, the pressure, adding more of a product, removing some of the product or the reactant, okay? So we're gonna take a look at this chart, and we're gonna kind of help you guys out along the way with this. But now, before I show you that, let me show you something else, because I think if you don't understand the chart, then everything else you do will be confusing. So I'm gonna switch off over here to this new screen right here so that you guys can actually see it, okay? And know what I'm talking about. So right here, when it comes to your reactants, and we kind of discussed this a little bit yesterday, that when you look at your equilibrium concentration values, sometimes things can be favored to the left, in the middle, meaning equilibrium, or to the right. And that depends on how large or how small your Kc is. So if you look at having a small number, okay, and looking at your exponent, if your exponent is negative, that typically favors the reactants. However, if your exponents are positive, that favors the products. If it's close to 1 or right at 1, they're equal. And this is where you have an equilibrium process, okay? So how does equilibrium change depending on the conditions? Well, let's talk about it. If you have the concentration, okay, and you add a reactant, okay, so when we talk about adding stress or the stressor, if you add a reactant, it's going to move forward. So the reaction to remove the stress is going to move forward. So if you add the reactant, it's going to move forward. If you remove the reactant, it's going to go backwards, so it's going to reverse. If you add products, it's going to go in the reverse. And if you remove products, it's going to go forward. If your professors aren't giving you a chart like this, I recommend that you would write this chart down, like, taking your notes, and then put it on a note card. I'm all about note card chemistry. I'm just going to start calling it like that, note card chemistry. And the reason is because when you're doing note cards, you want to take some of the things like your polyatomic ions. You want to take things like your diatomic molecules and put them on a smaller format, okay, a smaller, so basically you're taking your notes, okay? You're literally taking whatever you wrote in your notes and you're condensing them down to a smaller format. So you're taking your notes, condensing them down. So for something like this in a chart form, I would recommend that you put that down and say that if you add reactants and remove products, it's going to move forward. If you remove reactants and add products, it's going to reverse. So that way you're able to remember. Volume. If you decrease the volume, it's going to go towards fewer molecules in the gas phase. And if you increase the volume, you're going to go toward more molecules in the gas phase. Temperature. The difference between endothermic versus exothermic reactions. Endothermic is when you are raising the temperature. Think about an explosion, a combustible reaction. That's exothermic. Exothermic is when you're releasing the energy, okay? When you're releasing energy, an explosion occurs, heat occurs, that's typically positive, okay? When you are doing endothermic, you are absorbing, okay? And that's negative. Okay, JD, say that again. AH negative, right? What do you mean? So if you raise the temperature and it is an endothermic reaction, you're going to have a larger value for Kc, which means it's going to move forward, okay? If you lower the temperature for your endothermic reaction, it's going to go in the reverse. And you're going to have a smaller Kc. And finally, exothermic, if you raise the temperature, you're going to have a smaller Kc, and lower the temperature for an exothermic reaction, it's going to go forward and you're going to have a larger Kc. Okay, you say for exothermic, the delta H is negative. Yes, so you're talking about dealing with Hess law? Yes. Now, when you talk about a catalyst, it has no effect, okay? So whether you increase the rates, if you add a catalyst, meaning the catalyst is typically going to accelerate the reaction, it has no effect on the stress, okay? Has no effect on the stress. So now what I'm going to do, I know that was a lot to kind of remember, but I'm going to help you when it comes to this chart right here, okay? Again, this is what we said yesterday. Remember, like I told you before, if you have large exponents, notice how it's favoring the products, meaning the right-hand side. It's going to go forward, okay? However, if you have a negative exponent, then it's going to favor the reactants, meaning it's going to reverse itself. It's going to go to the left, okay? So let's go back to the other page that we had so that you guys can answer these questions right here, okay? Again, this is based on equilibrium, okay? This is based on equilibrium. So right here for your question, let's see if you guys can answer that. Okay, if you increase your temperature, is it going to shift to the left or to the right? Matter of fact, you know what I'm going to do? Let me copy that particular chart, because that way you can answer the questions a lot better, okay? So let me copy this chart right here, because that'll help you guys. So let me copy that one right here. Let's see. But I'm gonna have to make it a little bit smaller just so you all can answer the question. Okay, let's see here. Okay, there we go. There we go. So these two are together. So that way you all can answer the questions, okay? So for this particular part right here, where it says if you increase the temperature, okay, increase the temperature. So let's look at our chart. If we increase the temperature, okay, and they're talking about chlorine right here. What happens with chlorine? So I'm going to highlight chlorine because that's what they're talking about right here in the chart, okay? If you increase the temperature, what do you think is going to happen to your equilibrium position? Is it going to shift to the left or is it going to shift to the right? So if you increase the temperature, what do you all think is going to happen? So let me help you guys out. It's going to shift to the left, okay? And your chlorine is going to decrease. Okay? So if you look at your reactant right here, okay? If you're decreasing the amount of your product here, okay? You can see how this is the reverse. So it's like you're looking at this part right here where it says remove the reactant, because it's like you're decreasing it, okay? What about the pressure? If you decrease the pressure, what do you think is going to happen? Well, if you decrease the pressure, okay, again, it's going to shift to the left. And then what's going to happen to your chlorine amount? It's also going to decrease. Okay? A lot of times when you're answering questions like this, I would recommend, again, that you have a chart nearby. Okay? That you have a chart nearby. If you add oxygen, okay, and here's your oxygen right here. So if you add more of your reactant, okay, if you add more of your reactant, so you're adding reactant, it's going to shift to the right, okay? It's going to shift to the right, and the amount of chlorine is going to also increase, okay? The amount of chlorine is going to also increase. Next one, if you remove water, okay, which is on the other side, it's one of your products. If you remove water, So you remove your product, it's going to also move forward, okay? And your amount of chlorine is going to increase. And finally, if you increase your pressure, it's similar to, you can think of increasing your pressure, you can think of that as being similar to volume, okay? When you talk about the gas laws, they can be used interchangeably in this particular instance. In this case, they'll still move forward, okay? And the amount of chlorine will also increase. Now, and then this last one right here, okay? Let me erase this part. If you add water, okay? If you add water, so that means you're adding one of your products, okay? You're adding one of your products. Right here, it tells you it's going to go to the reverse. It's going to go backwards. And of course, the amount of chlorine you have is going to decrease. Okay, so as you guys can see, teachers give charts to see if you're able to interpret the chart with questions. And if you can't do that, that's not good, okay? So sometimes when you have chemistry questions, it's all about seeing how you're able to interpret data, charts, and graphs. Okay? Does anybody have any other questions before we get off today? I know some of you all were thinking that we probably weren't going to do chemistry since some of you guys are on spring break, but I say use spring break time to play catch up. Use that time to play catch up. You can relax the first 2 days, but then you want to get back in the groove of your work, okay? All right. Any other questions before we get off today? Anybody have any other requests before we end today? What's your question, Amon? What's your question? Okay. Solubility. Okay. Okay, got you. Solubility, okay. So I don't know if you were here with me yesterday, but we did do a solubility question. So let me go ahead and bring that up for you so that way you can see what I'm talking about. Okay, so we did do solubility yesterday. Yes. Let me see here. Okay, yes. So let me switch off the screen over here, so that my friends over here on YouTube can see it too. Okay, and thank you, Brooklyn. Appreciate that. Hey, Bridget, where you been? All right. So for solubility questions, we talked about this yesterday, so let me go ahead and recap so that way you'll know what's all this yellow stuff on the screen. So for solubility, it's based on aqueous solutions. You do not include your liquids nor your solids, okay? So if I told you to write out the KSP for this given reaction right here, okay? So as you can see, I kind of had some blocks going through it. You only consider these reactants right here, okay? You consider that, or the product rather, excuse me, the products, calcium plus oxalate. And then you put them in brackets, and that's your KSP. You do not focus on solids, so that's why those are blocked out. We did another example where we had calcium fluoride. So let me show you again here. With calcium fluoride, because it splits off into the ions of calcium with the 2+ charge and fluorine, we had to put a coefficient of 2 in front of fluorine to balance it off with the fluorine on the reactant side. So when we wrote it out, we wrote the KSP in brackets, we had calcium times fluorine raised to the coefficient, which is to the power of 2. So if you're able to do this part, then when I give you actual numbers and I tell you to plug those numbers in, you'll be able to plug numbers in to do the exact same thing. So for instance, in this case right here, you had a saturated solution of strontium fluoride. They gave us the strontium 2 plus ion, and they also gave us the fluorine ion. What we had to do was write out the balanced equation, because if they don't give it to you, you've got to write it out like this. That 2, I wrote the 2 in black because I wanted students to see that if you wrote it out without the 2, because you're thinking, okay, there's strontium here, and then there's fluorine, well, they're not balanced. So you've got to make sure that you put the 2 right there in front of the compound or the element in order to balance it out. Now that 2 is going to be your exponent or your power. So strontium with the 2 plus ion is in brackets. Fluorine with the negative charge is in brackets, but it's raised to the power of 2. And all you have to do now is plug in those numbers. Strontium's ion was 8.7 times 10 to the negative 4th power times fluorine's ions, 1.7 times 10 to the negative 3rd power. But then it was raised up to the power of 2 in terms of the exponent on the outside because of that coefficient that we discussed a second ago. And now all you have to do is plug these 2 into your calculator and multiply them, and you get this small number. Someone asked me yesterday, why not write it in decimal form? And I said, well, that would be tedious to do. So it's just better to write it out in exponent form. Was that the question that you had, Among? I know you said you wanted to know about solubility. Okay, you're welcome. Do you have any other examples on pure water competing reactions or common ions? Not right now, but here's what I want you to do for me, Among. Put that same comment that you just typed out, if you can, go to one of my latest videos, write that out or type that in so that that will remind me to create a video for you, and I'll do a video response, okay, for you as well on that particular question. Yes, I'll do that for you. So just make sure you go to one of my latest videos and put that in the chat box or in the comments, and then that way I'll do a video for you. I go live Monday through Thursday, 12 noon Eastern Standard Time. You're welcome. And I won't be live tomorrow on Friday, okay? So, Friday is Friday, as everybody says, Friday, because everybody's excited that the weekend is almost here. So I don't go live on Fridays, but I will be still putting out content and playing catch up with these videos, downloading them, chopping them up, and all that good stuff so that you guys can have access to this material, okay? So you guys have a wonderful, wonderful rest of your weekend, and I will see you all on Monday, same time, same place on these TikTok streets and YouTube, okay? You guys have a wonderful rest of your day, and thank you guys so much for joining me. Yes, thank you, Amon. Thank you. Thank you, Ethan. Thank you, Karen. You guys have a wonderful day. You're welcome, Melissa. Okay, YouTube. So I hope that you guys enjoyed this lesson with me today, where we did chemistry tutoring, and I go live again, like I said before, Monday through Thursday. And I'm starting this platform here so that, I can do this with you all as well, because I know sometimes, got some feedback. With me today, where we did chemistry. Thank you, Jerika. I appreciate that. Like I said, so Monday, Thursday. So guys, if you all have any other questions, by all means, make sure you all hop back on. So I start this one. I usually delay YouTube because I'm playing music, on TikTok, and I know sometimes there's a thing where you can't play music and stuff. So that's what tends to happen in terms of me delaying this. But I will be back on, and I'm so glad that several of you guys were able to join me over here today. And I will be back, and I'll keep this video up, okay? Nothing will be edited from this at all. So you guys have a wonderful day, and you all take care.